This is the next example. So standard form ax squared plus bx, this last number here is my y-intercept. So because it's my c value, 4, I'm going to go to 0, 1, 2, 3, 4. I'm going to write down y-intercept next to it. Don't care with anything, so I'm trying to pick orange, like a color that makes it easy. Axis of symmetry, x equals negative b over 2a, which equals negative times negative 3 over 2 times negative 1, which equals 3 over negative 2, which equals, oh shoot, wrong button, wrong symbol. X equals negative 1.5. So negative 1.5 is over here. I'm going to put a line here in the middle. Label that my AOS. Vertex, remember, comes from that, negative 1.5. Plugging that into my calculator. You can do it one of two ways. You can plug in with the mathematics, negative parenthesis, negative 1.5 squared minus 3 times negative 1.5 plus 4. You get 6.25, or y equals, type in this equation, you're going to have to anyways, negative x squared minus 3x plus 4. Okay, graph. That tells me that I'm going to have a max, which is cool. Second calc, a value. Plug in negative 1.5. Same answer. Two ways to do it. Yes, I do it both ways. Usually check myself. 6.25. So I'm going to come here. This is 4. Why is it where I put my y-intercept every single time? 4, 6.25, so roughly right there. Okay. That's my vertex. My y value is at 6.25, and as we already saw on the graph, because I already did that, it's a maximum. So now I'm going to do my points on either two sides. I can do the table or I can do the graph. I'm just going to do right 1, up 1, right 2, up 4, right 3, up 9. I'm going to talk about this. Your a value equals negative 1, which is why it's also a maximum. It was negative. That gets multiplied on your ups. That's your vertical stretch. So instead of going up, multiplying this by negative 1, it's really going to be right 1, down 1, or right 1, up negative 1. And if you go up negative 1, it's down 1. Right 2, down 4, right 3, down 9. So if I had this as a 2, or for example, like on number 2, it was a 4, I would take right 4, up 4. Excuse me, right 1, up 1 becomes right 1, up 4, because 1 times 4. So this is what I'm actually going to graph. So if I go right 1, I'm in the middle because it's 1.5. I'm going to go down 1, which is 0.25, so roughly right here. And I'm going to mirror that over. Okay. The vertex, or not the vertex, excuse me, the y-intercept here that I'm literally writing on is 1.5 over. So I'm going to go 1.5 over on this side. Okay. I'm going to go right 2, down 4. So right 2, 1.5, half down 4. So 1, 2, 3, 4. Then I'm going to go right 3, 1.5, 1.5, down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to mirror these over, so 2 over, so a half, 2.5. That's too far. You go to half, so 1, 2. There we go. And this is over 3, so 1.5, 1.5, 1.5, 1.5. And you can see how it works out. None of these are meant to be pretty for your zeros, which is frustrating. But you can see how your graph gets formed. Oops, that's a really bad straight line. Okay. Solutions, this is where I cross. They might be pretty, I don't know. I don't trust them to be pretty. They might be. So what I'm going to do is I'm going to calculate them out on my calculator again. Turn off that reflection light. There we go. So I'm going to go second calc, 0. I'm going to go to the left side, hit enter. I'm going to go to the right side of it, hit enter, enter. Ooh, that one's nice. So that is at -4. So this is 0, 1. I'm going to write that down here in a second. 0, 1 is at -4, 0, which is also your x-intercepts. So please know those are the same thing. Second calc, 2. Go to the left side, cross over, go to the right side. And that one was pretty too. Dang. 0, 2, 1, 0. So x equals -4, 1. And there's that graph. That was pretty sweet.